Hey everyone, welcome back to the channel. Today, we're stepping into the exciting world of organic chemistry to explore a compound called 2-Acetamido 6-methylpyridine. Whether you're a chemistry student, a lab enthusiast, or just curious about molecules, this video is for you. We're going to unpack its structure, properties, and what it might be used for. Plus, I've got some fun questions to get you thinking. Let's dive in. Alright, let's start with the star of the show, the structure. 2-Acetamido 6-methylpyridine is built around a pyridine ring. That's a six-membered aromatic ring with one nitrogen atom replacing a carbon, kind of like benzene's cousin. The name gives us clues about its modifications. At the 2 position, we've got an acetamido group. That's NHCOCH3, a nitrogen bonded to an acetyl group. And at the 6th position, there's a methyl group, CH3. This combo makes it unique. If you're new to this, pyridine rings are a big deal in chemistry. They pop up in drugs, pesticides, and more because they're stable and reactive in just the right ways. These substituents tweak how the molecule behaves. Pretty neat, huh? Next, let's look at its molecular makeup. The formula is C₈H₁₀N₂O, which breaks down to 8 carbons, 10 hydrogens, 2 nitrogens, and 1 oxygen. Its molar mass is 150.17 grams per mole. That's fairly light for an organic compound, suggesting it could be handy in applications where smaller molecules shine, like in synthesis or drug design. To put that in perspective, water's molar mass is about 18 grams per mole, and something like sugar is around 180 grams per mole. So, this compound sits in a sweet spot. Not too heavy, not too light. You might have noticed this number, 5327333. That's the CAS registry number, a unique identifier for our compound. It's like a chemical barcode. If you're researching or ordering this stuff, plugging that number into a database or supplier catalog will get you exactly what you need. No mix-ups. Every compound has its own CAS number, so it's a foolproof way to track down info or buy it from suppliers. Now let's talk about quality. The image lists 2 product codes, 01547-52 and 01547-62. And both have a purity of over 98%, checked by gas chromatography, or GC. That's awesome. It means less than 2% of what you get is impurities, making it top-notch for experiments or research. GC separates compounds based on how they travel through a column. A big, sharp peak for a compound tells us it's super pure, perfect for precision work. Thinking of grabbing some? It comes in 2 sizes, 5 grams for 5,900 yen, or 1 gram for 3,400 yen, priced in Japanese yen. The small quantities and jar packaging hint that this is a specialty chemical, likely for lab use rather than big industrial batches. The cost isn't cheap, but for a compound this pure, it's reasonable. Its pricing suggests it's niche, maybe for research or small-scale synthesis. If you're budgeting for a project, keep shipping from Japan in mind too. So what's the point of this compound? The image doesn't spill the beans, but let's brainstorm. Pyridine derivatives are stars in pharmaceuticals and agrochemicals. That acetamido group could form hydrogen bonds, which is gold in drug design, helping molecules stick to biological targets. Maybe it's a stepping stone for making medicines, or a reagent in organic reactions. What do you think? Could it be a catalyst or a drug precursor? Drop your ideas in the comments. I'd love to hear your take. The image doesn't list storage details, but here's a pro tip. Organic compounds like this usually need a cool, dry spot. Think a desiccator or sealed jar away from light and moisture. Check with the supplier for specifics, but safe handling keeps it stable for your experiments. Curious how this compound comes to life? We don't have the recipe here, but substituted pyridines often come from reactions like the C₈H₁₀N₂O method, or tweaking existing pyridines. Maybe you'd start with 6-methylpyridine and add that acetamido group via acetylation. It's like molecular cooking. Here's a challenge. With a molar mass of 150.17 grams per mole and that polar acetamido group, what do you think its boiling point might be? High, low, or in the middle? Look it up if you can, and share your guess in the comments. I'll check them out. Alright, that's our deep dive into 2-acetamido 6-methylpyridine. We've covered its structure, properties, and some cool possibilities. Chemistry's all about exploration, and I hope this sparked your curiosity. If you liked this, smash that like button, subscribe, and hit the bell for more chemistry adventures. Tell me in the comments, what compound should I tackle next? Thanks for watching, and I'll catch you in the next one.